Hi and a very good morning to all the panelists this WhatsApp. My name is Farah Natasa binti Zakri and I am team leader of Endeavour. And our advisor name is Technologist Dr. Muhammad Hazri bin Muhammad Lui, who always help us to understand what is CANSET and how it works. And this team Endeavour, we have four group members, including myself and Muhammad Helmi, Muhammad Nizamuddin, and Muhammad Amirul. Each person has their own specific tasks and roles. Before we move to the ground system terminal, our mission objectives for this competition is to determine the CANSET design and ground system terminal components, and also to synthesize the working system in CANSET related with engineering education. It also to evaluate the data received in ground system terminal. Okay, the CANSET missions to carry out the scientific experiment by measuring a various characteristic at different altitudes and transmit the data in 1 second interval and achieving a safe landing. For data acquisition, CANSET will collect the data such as altitude, pressure, humidity, and location determination. Once it's released in altitude of 200 meters and transmit the data to the ground system terminal in real time. Alright, okay. For the ground system terminal, the payload microcontroller will collect sensor data and send it to serial to transmitter, and then the receiver antenna will boost signal reception and send and retrieve packets at the receiver telemetry. Next, the USB adapter enables the receiver to USB connection, and the laptop interfaces with USB adapter, hence it can plot data and saves it to CSV file. Okay, for the telemetry display, the data logging, display, and image receiving will be displayed by using custom Python and GUI. For the real-time plotting software design, the Python program reads serial inputs from the 3DR telemetry and plots it using Python library, all inside in one GUI. And for the common software in interface, the GUI sends the common serial to the transceiver.
Okay, Assalamualaikum warahmatullahi wabarakatuh, and my name is Muhammad Ilmi. Now I'm going to present about electrical and power subsystem. Our main component in our CAN satellite is microcontroller. We are using two types of microcontroller. One is APM 2.8 and Raspberry Pi 0W. Okay, those microcontroller need input from this type of sensor. One is barometer, camera, GPS module, pressure and temperature sensor, in order to gain all the information that we need to complete our task. Next is the power supply that we use in our system. So we are using two type 3. One is 1500 milliamp hour lithium polymer battery, and one is 800 milliamp hour OK cell lithium polymer battery. Okay, next I'm going to explain about the design of our chassis and our CAN satellite. Start with the material of the chassis. We are using acrylic sheet instead of aluminium, because aluminium is heavier and more expensive than acrylic sheet. Even though acrylic sheet is more cheaper and more easier to handle, the acrylic sheet also a strong material that can hold on our component while the satellite is up in the air. Next is our base shape. What this mean, the base shape is our side base shape. We are choosing a hexagonal shape instead of round shape, because hexagonal shape have more stability while in process, because if the base is round and the ground is not a flat ground, so the satellite might moving around or might falling from a cliff or anything. So we use hexagonal shape to prevent the accident to occur. Next is our orientation of CAN satellite while dropping from 200 meters above. We are using horizontal orientation, because horizontal orientation can give us enough air drag to save our CAN satellite from falling too fast from the sky. So we are using horizontal orientation to help to gain the maximum air drag for our parachute. So that's all, I think, for our design, and thank you.
For on-board data handling subsystem, the design consideration and requirement are based on HISWASAT requirement, and we have planned to try to fulfill all the requirement and considerations set by HISWASAT in order to achieve our mission. For flight software, Arduino Pilot 2.8 can collect data sensor and GPS signal, and the firmware must be loaded using APM software by programming it using Arduino programming language. APM software used to run on PC, and load the firmware to control the Arduino Pilot flight controller using USB cable. Okay. For processor part, we use Raspberry Pi Zero for controlling the sensor and the camera using the I2C and CSI port, and program the Raspberry Pi using Python language. For valid subsystem, we choose BME to S0 because the communication protocol is I2C, which is very compatible with Raspberry Pi Zero. It also have low voltage supply and faster data rate transfer than other sensors. It have all the sensors that we want to use in our CAN set in one component, which is humidity, temperature, and altitude sensor. Okay, next, we also use external barometer, which is BMP180 for altitude reading. We use external barometer to gain more accuracy, and if the main sensor is malfunction, it can be connected to autopilot using I2C interface. Okay, next, for GPS sensor module, we use a strong satellite searching capability module, which is U-Block Neo 6M, which is for giving location information to ground control station by connecting it to autopilot. For bonus mission, which is to transfer image capturing during flight, the camera that we choose is mini 5M pixel camera, which is very durable and using CSI interface by just plug in the camera to Raspberry Pi Zero.
I want to apologize to all the panelists because for this moment we cannot provide the progression working because a few items that we have buy still not arrived and not in our hands yet. This pandemic situation really challenges us, but as long as we working as a group, okay, everything just easy and we can do it better because everyone helping each other, even though each member has their own rules and parts, but we discuss in each other among ourselves which one is better, and we going through the article and we read the review. Okay, I'm going to show you our milestone and also the Gantt chart. We're going to predict that we're going to finish this building CAN set before the CDR submission, and after the CDR submission we will improve which system are lack, and we are going to improve that things after the CDR submission. And that's all from us. Thank you very much.